Yeah, good morning. The main objective of this presentation is to give an idea about what is additive manufacturing and what are the different terms associated with additive manufacturing, what is slicing, what is called a STL file, what is the format ASCII format, and what is the importance of ASCII format, or what is the relevance of ASCII format. Then what is called a watt photopolymerization, and what are the classifications as per ASTM, etc. So these are the main objectives, main objective of this presentation. So I'm starting with the definition of 3D printing. 3D printing, also known as additive manufacturing, is the process of creating three-dimensional objects from a digital file. So it is the process of creating three-dimensional objects like this from a digital file. First of all, we have to prepare the digital file. Digital file means we have to prepare the CAD file, computer-aided design file, with the help of any software. Unlike traditional subtractive manufacturing methods, which involve cutting away material from a solid block, 3D printing builds up objects layer by layer, hence the term additive. So the basic difference between subtractive manufacturing and additive manufacturing, for example, I am taking drilling operation. If I want to make a hole of diameter 6 mm in the workpiece, so I will use a 6 mm diameter drill bit, so that I will remove material from the workpiece. So that's why that machining is called a subtractive manufacturing. So we are subtracting material from the workpiece, from the raw material. But in the case of additive manufacturing, we are adding layer by layer. That's why this technique is called a layered manufacturing, or layer-based manufacturing, or layer-oriented manufacturing, so on. Again, this is called additive manufacturing. Additive means we are adding layer by layer. After printing one layer, then the next layer, the second layer will print on the top of the first layer, and so on. So that's why this manufacturing technique is called additive manufacturing. And the drilling operation is called subtractive manufacturing, means we are removing material from the workpiece. As per the ASTM, American Society for Testing and Materials, ASTM classified 3D printing into 7 different categories. One is watt photopolymerization, material jetting, binder jetting, material extrusion, sheet lamination, powder bed fusion, directed energy deposition. So this classification is based on the usage of energy. So as per ASTM, watt photopolymerization is using less energy, whereas directed energy deposition is using more energy. More energy is consumed by the directed energy deposition. One of the main important file we are using in 3D printing technology is called a stereolithographic file, or STL file, or standard triangulation language, or standard tessellation language. So what is standard tessellation language or standard triangulation language? It is a file format used in 3D printing and computer-aided design. It represents 3D surfaces as triangular meshes like this, and is a widely accepted format for 3D printing technology. Stereolithography is also the name of the 3D printing technology that gave rise to the STL file format. So STL file format means our 3D. Here I am going to print this face of this human being. So the first STL file is representing. I can say the resolution is less. For the first STL file, the resolution is less. In the second file, the resolution is medium, and in the final STL file, the resolution is more. Okay, so we will get more detail when the resolution is more. Resolution is more means the triangle is more. So STL means our CAD file, our digital file, is converted into a triangular mesh. That triangles are interconnected together. So that is what is called a STL file. Then another effect. This is a negative effect, that is called a staircase effect. As I already mentioned, in 3D printing technology, or in additive manufacturing technology, we are adding we are adding thin layers one by one so that we will get the final product. That's why this is called additive manufacturing. We are adding layers. Here in this picture, we can see first layer is N. The second layer, on the top of the first layer, the second layer will print. Then on the top of the third layer, second layer, third layer will print like that till the last layer we will print so that we will get the final finished product. But when during the printing process, because of some offset distance, what happens is on the right side or on the left side, we can see there will be a small offset because of the offset distance. So because of this offset distance, there will be a we can see the printed object on the right side or on the left side looks like a staircase. The side view of the staircase. We know that the side view of the staircase. So this in this image we can see uh, the the object's right side looks like the side view of the staircase. This is a negative phenomena. This effect is called a staircase effect. So during the post-processing operation or during the finishing operation, we will remove this staircase effect. We will remove this staircase effect by doing some finishing operations or doing some polishing operations, etc. So the layer by layer process in 3D printing often leads to a staircase effect, resulting in high surface roughness. So because of this staircase effect, surface roughness increases, particularly on curved and inclined surfaces. However, this effect can be significantly reduced by carefully selecting manufacturing parameters such as layer thickness and part orientation. So whatever technology or whatever material we are using, whatever complexity in the geometry, the basic steps involved in the 3D printing technology is same. If I am using clay as the clay as the material to using 3D printing technology, or if I am using concrete, or if I am using plastic, or if I am using any other material, whatever material we are using, or whatever geometric complex, whatever complexity is involved in your design, the basic steps involved in the 3D printing process is same. The first step is to prepare the design in any CAD software like CATIA, ProE, Tinkercad, Inventor Professional, Fusion 360. You can use any CAD software to prepare the part design. Then the next step is we will convert the part design into STL format. I already explained what is an STL format. It's a file consisting of triangular meshes. Then we will convert this STL file into a slicer software. So there are different types of slicer software available in the market. The Ultimaker Cura is one example. IdeaMaker is another example. That IdeaMaker slicer is from Raise 3D. Ultimaker Cura is the slicer from Ultimaker company. Then we will slice the STL file, and then we will upload, or we will copy the sliced file from the slicer software to the machine, and then choose the sliced file, and then click start printing operation. 3D printing machines are completely automatic. There is no complexity involved. You have to choose the file and you have to click the start printing operation. Then the machine will start printing. Okay. After building the process, we will remove the material, and then there are two types of materials involved in the final part. One is support material and another one is the part material. We have to remove the support material during the post-processing operation, and finally the part we will share this part to the specific department so that they can use the final part for their use. So the 3D printing process involves several steps mentioned here. Step number 1 to 8. First one is design the part in the CAD software. Then after that we will convert the design into STL file. Then we will prepare the file for printing using the slicing software, and then transfer the file to the 3D printer, set up the printer and start the printing process. And once the printing process is completed, we will remove the printed part from the platform and eliminate support structures and perform the post-processing operations and deploy the printed part for its intended application. Then when we are dealing with the 3D printing technology, as I already mentioned, this is a layer by layer manufacturing technique. We are adding layers, okay, one by one. So the thickness of layer is a very relevant factor during the 3D printing technology. If the layer thickness is very small, like for example in the figure you can see the layer height is 0.1 mm, it will take printing time of 55 minutes and 44 seconds. But if I'm increasing the layer height to 0.3 mm layer height, the printing time is reduced to 20 minutes and 40 seconds. Yeah, obviously, of course, the printing time is reduced. If the layer thickness is reduced, the printing time is increased, and if the layer thickness is increased, the printing time is reduced. That is, of course, that is a common phenomenon. But again, if the layer thickness is very high, it will affect the quality of the print. So we should choose the proper value of layer thickness so that we will get a perfect object with less surface roughness. The layer height in 3D printing, also known as layer thickness, layer resolution, or z-axis resolution, determines the thickness of each individual printed layer. It is measured in millimeters or microns and indicates the level of detail along the z-axis of the part. Thinner layer results in higher detail. Then coming to the next topic, that is the support structure. When we are printing the object, because of the complexity, because of the overhanging features, we have to provide support structures. For the overhanging features, if we are not providing the support structures, what will happen? Because of the gravitational force, the material coming out from the extrusion, coming out from the nozzle, that will directly move to the platform. Okay, so that we will not get the proper shape. So for the overhanging features, we have to give proper support structures. So when the orientation of support structure is a very relevant. So support structure means when we are considering the cost, uh, there are two types of cost related to the material. One is part material, and the second one is support material. So if I am orienting the part correctly, I can eliminate the use of support structures. This is clearly mentioned in this figure. So consider the first figure. This is a T shape. It is upside down. When I am orienting my part like this, there is no need of support structures. But see the last figure. If I am orienting the T shape like this, I have to give two support structures, one on the right side and one on the left side. And check the middle figure. If my orientation is like this, I have to give support structures. So proper orientation is very relevant in the case of 3D printing technology. That means it will directly affect the cost of the printing. Part orientation determines how the print head moves to construct a part, including the direction of travel between layers, which ultimately defines the shape of the layers. While all FFF, fused filament fabrication, or FDM, fused deposition modeling 3D printed parts, have visible layer lines, a part that is improperly oriented will have more visible layers. CSG approach. I already mentioned the first step involved in the 3D printing technology. Whatever geometry whatever complexity is involved in the geometry, whatever material you are using, whether it will be concrete, whether it will be clay, whether it will be plastic, whether it will be any other functionally graded material, or whatever material you are using, the first step is design the virtual file in any one of the CAD software. Okay, so there are different approaches we are using in different softwares. So one approach is called a CSG approach. So CSG approach means constructive solid geometry. Constructive solid geometry means we are using basic primitives such as sphere, cylinder, cube, hemisphere, etc. Then we will apply the Boolean operations such as addition, subtraction, union, intersection. So after applying the Boolean operations, we will get the final part. So this type of approach is called a CSG approach, or constructive solid geometry. Constructive solid geometry, commonly known as CSG, is a powerful technique utilized in solid modeling to create complex three-dimensional shapes and objects. This method enables modelers to construct intricate surfaces or entities by employing Boolean operations such as union, subtraction, intersection to merge simpler geometric primitives such as cubes, cylinders, and spheres. Autodesk Tinkercad is a perfect example of the approach called a constructive solid geometry. It is a user-friendly web-based 3D design and modeling tool. It is commonly used by hobbyists, educators, and beginners to create 3D models for purposes such as 3D printing, digital fabrication, and simple prototypes. Tinkercad features an easy-to-use interface with a drag-and-drop functionality, which makes it accessible for individuals without prior experience in CAD software. The tool is owned by the company named Autodesk. Then feature-based modeling. I already mentioned the kind of CSG approach, that is called constructive solid geometry. Another approach is called a feature-based solid modeling. The latest softwares, the recent softwares, the latest advanced softwares we are using, such as Inventor Professional, Fusion 360, CATIA, ProE, all those softwares are using feature-based modeling, and also those softwares are supporting parametric modeling also. So let's take an example. So I am planning to design a cube. Okay. So first I will prepare the sketch. That is the base of the cube. That is the square. I will draw a square. Then after that I will choose a feature called extrusion. Then I will, with the help of that feature, extrusion feature, I will extrude the sketch to a certain distance so that we will get the cube. So this type of modeling is called feature-based modeling. So there are different types of features such as revolve feature, sweep feature, loft feature, rib feature, mirroring, filleting, chamfering, uh, etc. So these types of softwares are called feature-based modeling softwares. Then ASCII format. ASCII format is which stands for American Standard Code for Information Interchange. It's a type of text file format that uses a standardized character encoding scheme. This standardized format allows information to be easily imported into various programs and software applications, regardless of the program in which the data originated. ASCII files are commonly used for storing and exchanging text-based data. So this image represents the ASCII format of a cube. So when we are considering the cube, we know that it consists of 4 vertical faces and 1 bottom face and 1 top face. That means total 6 faces. So on one face consists of 2 triangles. So that means 6 multiplied by 2, it consists of 12 triangles. So that is an STL format of the cube. Okay. So this is representing this ASCII code. This ASCII code is representing the STL format of a cube consisting of 2 triangles on one face. So this image, as we can see this one, the first triangle in the ASCII format. We can see vertex, vertex, vertex that represents the 3 vertex and the facet normal also. So like that, we can see in the one column, you can see 3 triangles, 1, 2, 3, a total 1, 2, 3, 4 columns. So 4 multiplied by 3, 4 into 3, 12. There are 12 triangles. So I will show you the ASCII code of a cube. So this is the ASCII code of a cube. So I will select this code. Here you can see this is the first triangle. You can see vertex, vertex, vertex. So in a triangle consists of 3 vertexes, right? So this is vertex 1, vertex 2, and vertex 3, and the facet normal. So this from line number 2 to line number 8 represents one triangle. Then from line number 9 to line number 15 represents the second triangle, like that. So I'm copying this ASCII code. Okay, then I will open the notepad. So this ASCII code is, okay, file, new tab. Okay, then I will paste here. So this is the ASCII code. This is the ASCII, this is the text format code of cube. Okay, then I will click file, save as. Then I will give one name called cube for printing, dot stl. Okay, I have to give the extension also, cube for printing dot stl. I will click save option. So now I saved the cube in the format of ASCII format. Then I will close this. Then I will open the Ultimaker Cura, the slicer software. I am opening the Cura software. So it will take some time. Okay, So it's opening. Okay, so this is my Ultimaker Cura. I will click File, Open Files. Then you can see Cube for printing. Click here, Open. So now you can see the cube is loaded into my printer. Here I am using Artillery Sidewinder X1 3D printer, and the cube is displayed. Okay, so I have prepared the ASCII code and convert that into .stl format, so that when I will open that ASCII code in the slicer software, you can see the cube is generated. Okay, then I'm slicing the file. So this will take 10 minutes. Okay, and if you want to see the preview, you can click this preview and click the play button. So this part will take 10 minutes to print. Yeah, I'm closing this. Yeah, that's about the ASCII code. Then coming to the surface deviation and normal deviation, as I already mentioned, our the first step is to prepare the CAD file. That is the first step. Whatever geometry we are using, whatever material we are using, the first step is to prepare the CAD model. Then the next step is to convert the CAD model into an STL format. When I'm converting my CAD model into an STL format, I already told you, STL format means consisting of infinite number of interconnected triangles. So let's take an example. If my object's outer boundary is in the form of a curved shape, and when I'm converting this object into an STL file, what happens is there will be a small gap. This is the one edge of the triangle, and this is the outer boundary of my actual model. So there will be a small gap. Okay, this is actually a problem. Our aim is to make our aim is to reduce this value to a minimum. Okay, so this value, this gap, this is called a surface deviation. Okay, and this angle is called normal deviation. Then coming to the next topic, that is the cost calculator. Okay, when we are doing the 3D printing operations, we have to consider different factors, such as what is the cost of the material, what is the cost of part material, what is the cost of support material, what about the pre-processing cost, what about the building cost, what about the machine utilization cost, what is the cost of operator. Okay, and then what about the post-processing cost. So we have to consider all those aspects. So when we are checking the website of Prusa, they are providing an online 3D printing calculator. This is the 3D printing price calculator from Prusa Research, so that you can give all the data, so that the application will give you the cost. When we are Okay, so coming back to the presentation. So the total cost. So the total cost of a 3D printing will be equal to pre-processing cost plus machine utilization cost for building the object plus material cost. Material cost means the main material and support material, and finally the post-processing cost. The coming to the pre-processing cost. The pre-processing cost will be equal to, this is time. Time means the model position time. We have to add 4 times model position time plus support generation time plus model slicing time plus toolpath generation time multiplied with the staff cost per hour plus the computing facility cost per hour. Okay, that is the first value, plus T setup, that is the machine setup time multiplied with the again staff cost per hour plus machine utilization rate. When you solve this, you will get the pre-processing cost. Then what is machine utilization rate? There is an equation that is m plus c by t divided by 365 divided by 15, where m is called annual maintenance, which is equal to 15% of c, where c is called initial machine cost, and t is the machine life. Then coming to the build cost. Okay, build cost is equal to build time multiplied with the machine utilization rate. Again, machine utilization rate is m plus c by t divided by 365 by divided by 15, where m is the annual maintenance, that is 15% of the initial machine cost, that is c, and t is the machine life. Material cost, so we know that the main material cost plus the support material cost. Add main material plus support material, we will get the material cost. Then post-processing is post-processing cost multiplied with the staff cost per hour plus the miscellaneous cost. Miscellaneous cost such as for stereolithography, we are using UV oven or hot isostatic pressing for metal or waterworks for fused deposition modeling. Okay, so these are the, when you add all these values, we will get the total cost. So total cost will be pre-processing cost plus machine utilization cost plus material cost plus post-processing cost. Then next is the slicing. Slicing is a very important term related to 3D printing technology. What is slicing? I already mentioned slicer software. Slicer software such as Ultimaker Cura. Ultimaker Cura is one slicer software. Idea Maker from Rise 3D is again a slicer software. So what is slicing, or what is the duty of the slicer software? So slicing means, as I already mentioned, this is a layer-based manufacturing. We are adding thin layers layer by layer. So we have to split our object into thin layers. That process is called a slicing operation. There are various types of slicing types, such as one is first one is related to the file. Okay, uh, we are converting the digital file, the CAD file, into an STL format. That type of then we will slice the STL file. This type of slicing is called indirect slicing. So indirect slicing means we are using an intermediate format, that is called indirect slicing. But in the case of direct slicing, we are using the CAD file directly, and we will convert that file into the sliced file. There is no intermediate format. That is what is called a direct. So that is the difference between direct slicing and indirect slicing. Then coming to the next topic, that is the uniform slicing and adaptive slicing. Uniform slicing, from the name itself, we can say the layer thickness will be uniform from starting to the end of the printing process. The layer thickness will be uniform. So this type of slicing is called a uniform slicing. And in the case of adaptive slicing means the layer thickness will be different. So let's take an example. If a part consists of 1,000 layers, and from first layer to the 500th layer, the layer thickness will be X millimeter, and the remaining layer thickness will be Y millimeter thickness. So this type of different layer thickness we are using, that is what is called adaptive slicing. So that is related to the layer thickness. The first classification is related to the intermediate file we are using. Then horizontal slicing and conformal slicing. Horizontal slicing means we are slicing the part horizontally. That is what is called horizontal slicing. But in the case of conformal slicing, the best example to explain conformal slicing is the case of onion. We know that the onion consists of different layers, and consider the outer layer. The shape of the outer layer will depend on the previous layer. What is the shape of the previous layer? According to the shape of the previous layer, we will get the outer layer of the onion. That means the 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 second layer will depend upon the first layer, or the third layer will depend upon the shape of the second layer, or fourth layer will depend upon the shape of the third layer, etc. So this type of slicing process is called this type of slicing process is called conformal slicing. We are using functionally graded material. We can whatever any type of material we can use in the 3D printing technology. Okay, for example clay, for example concrete, for example plastic, for example functionally graded material means it is a combination of, here in this image you can see, the last figure you can see, it's a combination of ceramic and metal. So this type of to get the specifications, or to get the quality of both ceramic and metal, we are merging two materials. So that is what is called a functionally graded material. So here you can see functionally graded material that consisting of ceramic and metal. Then coming to the next topic, that is what is called a resolution in STL file. As I already mentioned, resolution means the number of triangles. The number of triangles used in approximate a surface in an STL file significantly influences its resolution and its size. When creating an STL file, it's important to consider that a low resolution file may result in visible facets during the 3D printing process, adversely affecting the final output. Conversely, a very high resolution STL file can produce an excessively large file size, making it challenging for 3D printing software. These are the two slicer softwares. One is Ultimaker Cura. Cura is highly regarded open source slicing application tailored for 3D printers. Originally developed by David Bra, the software is known for its user-friendly interface and powerful features. After creating the application, Bram was later employed by Ultimaker, a leading 3D printer manufacturing company, to continue developing and maintaining the software. Then the second one is Slicer software. The name of the software is called Idea Maker. Idea Maker is a sophisticated 3D slicing software designed to automate the generation of support structures while also offering a comprehensive suite of tools for manual editing and advanced applications. It boasts features such as PBA support, the ability to create robust and stable support structures, the capability to generate easily removable support structures, and the option to reduce excessive support material for more efficient printing. Then coming to the topic called photopolymerization, this topic is related to the technique called stereolithography. In stereolithography, we are using liquid as the raw material. That means that is photocurable liquid resin. We are using photocurable liquid resin as the raw material we are using. It's a photochemical process that involves the use of catalyst to initiate a reaction between small monomers. This reaction results in the formation of a chain-like polymer. Photopolymerization is commonly used in various applications such as 3D printing, coatings, and adhesives due to its ability to achieve a rapid and precise polymerization under controlled conditions. See this figure, see this image. So from the first figure, you can see the photocurable liquid resin consisting of photoinitiator and a monomer. When this photocurable liquid resin under the exposure of UV light, it will harden from liquid form to the solid form. So the process is like this. When under the exposure of UV light, the black color is representing the photoinitiator and the golden color is representing the monomer. Under the exposure of UV light, the photoinitiator excited and free radicals generated free radicals. Then after that, the photoinitiator will share this free radical to the monomer. In this way, a bond is created between the photoinitiator and the monomer. This is called a chain initiation. Okay. So then after initiation, after chain initiation, chain propagates and we will get the solid shape. So this is the process involved in the case of uh, photopolymerization. Okay. So here we are using liquid as the raw material, that is photocurable liquid resin. So under the exposure of UV light, the photocurable liquid resin is converted into solid form like this. So this one is a 3D printing machine. I am showing this 3D printing machine from Ultimaker. The name of this machine is called a Factor 4. This is an industrial grade performance, reliable and repeatable results 3D printing machine. And this printer is using the technology called fused deposition modeling, FDM technology. This machine is using, and the build volume size is 330 by 240 by 300. That means we can build, we can print the object with the maximum size of the object we can print is 30 centimeter. So next topic. So with this, I'm stopping my presentation. So I'm concluding. So what is additive? So I have explained what is additive manufacturing. What are the important terms related to additive manufacturing? What is called a slicing? What is STL file? What is the use of slicer software? Then what is that? Then the classification as per ASTM based on the energy consumption, from low energy consumption to high energy consumption. Then what is called the photopolymerization. Then different types of 3D printers, etc. Then the next topic is related to a contest, a competition. The name of that competition is called a World Skills Additive Manufacturing Competition. So World Skills is like an Olympics. Okay, we know that World Cup football, World Cup cricket. Okay, so the different countries are competing. Topmost skills from each country will compete. That is what is called the world skills. So top uh, top cricket team from India and top cricket team from Pakistan will compete. That is called a World Cup cricket between India and Pakistan. Same way, um, the top skill performer in CNC milling will compete with the top performer from France, like that. Okay, so the competition will be like that, country versus country. So it's a wonderful opportunity to those who are interested in exploring uh, about different types of skills. There are so many skills such as CNC milling, CNC lathe, additive manufacturing, industrial design technology, then IoT, Industry 4.0, manufacturing technology, mechanical engineering, CAD, digital fabrication. There are n number of skills. Okay, whatever skills you are interested, you can read the document and you can join. Okay, it's a wonderful opportunity. So this is the link about if you want more details about additive manufacturing world skills contest, you can click this link. Under the world skills additive manufacturing competition. Okay, so this is the page, additive manufacturing, and you will get all the details from here. Okay, so in 2022 the gold medalist was Shun Lee Sit. He is from Singapore, and the silver is from China, Wai Tong Lin. Okay, so this is the result. So when you are winning like this gold or silver, you are representing your country across the world. Okay, so in that case you will make your country proud. So this is a wonderful opportunity, so please utilize this. Yeah, another competition is called a mechanical engineering CAD competition. Yeah, we know that for additive manufacturing we have to prepare the CAD file. Okay, so this is related to this is not related to, but the mechanical engineering CAD competition mainly focuses on the preparation of virtual models such as part design, assembly design, etc. Okay, so the students, they have to apply the concept of reverse engineering also. Reverse engineering means they will give a machine part, and they will give all the tools such as vernier caliper and all other tools. The student will be able to reverse engineer the product, and the student, they have to prepare the virtual model in the CAD software they are providing. So this is, if you want more information about this skill, that is called a mechanical engineering CAD, click this link, you will get more details. Okay, so here you can see the results. So in World Skills Competition 2022 Special Edition, the gold, he is from he is from Portugal. His name is Joa Teixeira. And again gold, he is from Korea. His name is Jaeyoon Lim. And the bronze, um, he is from Lucas Dolinar. He is from Austria, and his name is Lucas Dolinar. And one more bronze will be there. His name is Susheng Shen. He's from China. Okay, so that's all about my presentation. So if you are more interested in learning more about additive manufacturing, so you can click, there are different links I have provided here in this website. So if you want more information about, for example, if you want more information about slicer software, just click the link. You will get more details about the slicer software. For example, if you want more details about functionally graded materials, just click here. You will get more details about what is called a functionally graded material. So read this document, you will get more understanding about functionally graded material. Okay, if you want to explore more, you can explore by clicking the link. Okay, so with this, I am stopping my presentation. So I hope everybody got an idea about 3D printing technology, different 3D printing machines, and its capabilities, etc. Okay, thank you so much.